Introduction to Registers. In the previous tutorial, we discussed counters and various types of counters. Now in this tutorial, we are going to discuss registers. Do you know what is meant by a register? Before discussing the definition of registers, let's question ourselves about what is the use of these registers and why should we know them. Do you know why? Well, let's talk about it. We all know that computers perform complicated tasks only because the programmer has broken those tasks down into a sequence of simple, primitive operations, like moving information and performing simple arithmetic and logical operations. To perform these operations in sequence, we must somehow remember the results of the previous operations. So even for the simplest computations, we require memory. For example, let's take our pocket calculator. In that, if we want to add 4 and 3, then first we need to press 4, so the calculator must remember the number. Then we press plus. Then the calculator remembers 4 and add. Now we press 3. The calculator remembers 4, add, and 3. And finally, press equal, and the calculator works out the answer and remembers it, so it can be displayed. To achieve this kind of functionality, we need a circuit that can remember binary numbers, and that circuit is a register. Now, I hope you understand the purpose of a register. Now, let's discuss a register and what it does. A register is a digital electronic device capable of storing several bits of data. A register is a group of flip-flops. We know that each flip-flop is capable of storing 1 bit of information. An n-bit register consists of a group of n flip-flops that are capable of storing n bits of binary information. Do you know that registers have combinational gates? Yes, in addition to the flip-flops, registers may have combinational gates to perform certain data processing tasks. These registers perform 2 basic functions. They can store data, or they can transfer data. These functions are done by combinational gates. Registers are fast access memory elements found inside microprocessors, microcontrollers, and so on. Like counters, various types of registers are available commercially. Before discussing the types of registers, we will discuss the simplest register to make you aware of how registers look and how they work. And in the next tutorial, we'll discuss the types of registers. Now, let's talk about the simplest register. The simplest register is one that consists of only flip-flops without any gates. Here's the circuit for you. From this circuit, it is clear that the register is constructed using 4D flip-flops. Here we have 4 inputs, 4 outputs, clear signal, and a common clock for all flip-flops. Now, let's see how it works. First, we need to clear or reset all the flip-flops. Then we will apply the clock pulse to all the flip-flops simultaneously. The common clock input triggers all flip-flops on the positive edge of each clock pulse, and the binary data available at the 4 inputs is transferred into the 4-bit register. Now, the 4 outputs can be sampled at any time to obtain the binary information that is stored in the register. The clear input goes to the R input of all the flip-flops. When this happens, the R input goes to 0, and then all the flip-flops will reset again. Here, R is nothing but reset. You may wonder, what is the use of this clear signal? This clear signal is very useful for clearing the register to all zeros prior to its clocked operation. These R inputs must be maintained at logic 1 during normal clocked operation. Now, I hope you have some idea about registers. So let's move on to the next tutorial, which deals with shift registers.